Good morning, everyone. Welcome to my talk. This talk is about clean architecture and the benefits of modularizing Android apps. This is going to be a talk about Android specifically. We're going to see some more general concepts about software engineering and particularly clean architecture and also modularization. First off, I hate to break it down to you right now. This is a talk which is possibly could become very, very long and very big. It's involving two different aspects of software engineering that, particularly in Android, that could be pretty big. So we're gonna kind of trying to exclude some topics from the discussion. Mainly, it's about topics that actually pertain to Android development, which is dependency injection in depth that I assume that as a standard, and also about modularizing apps. Surprisingly, if you think about that, but there's plenty of literature also how to carry out a complete modularization of a monolithic piece of software. And also we won't be covering build system setups because we're going to assume that we have just a simple Gradle setup for the current project. We're going to see some principles first. And then after, I'm going to show you some code that I wrote down while developing stuff for this talk and just on our personal projects. So let's begin. So let's go ahead with the clean architecture overview. How many of you have heard about clean architecture before? Few hands, not too many. Okay. So clean architecture is, very briefly, it's a giant argument, as you can imagine. It's an approach which can be applied to several, to the software engineering in general. So it can be applied to any organized software system. And it's basically, its foundations were laid down by several authors, and the main one is Uncle Bob, Robert C. Martin. And what you see mainly when you're reading through clean architecture principles, you mainly see these kind of structures and representation. This is the Android version of the Android interpretation of that kind of architecture, where we have a series of concentric layers where we define the functionality of our app, of our project, which involve entities, use cases, presenters and data, UI and data sources. Why is this concentric? Because it defines naturally a hierarchy between the importance and the immutability of the layers of the software that we have. Just think about the most centric part of the app, which is entities and use cases. In this case, we talk about these objects and these components of the software as the business logic of our project, which means all the rules and the objects that define what our project is going to do. We're going to see an example about a news reading app, for instance, which is going to literally retrieve from the network a list of articles from a news sources. So entities and use cases define what our app is doing. What is it doing? Retrieve the list of sources and show it to the user, or retrieve the list of news articles and show to the user. Then if we move outside, we find presenters, which is the typical presenter in Android logic. So we can think of about all the presenters and view models that we have in our project. The UI is the layer taking care about having fragments, activities, and all the components that pertain to presenting the information to the user. And if we move further down, we find data, which is a very shallow layer, a thin layer, which is responsible of defining the rules of how we interact with our data inside our app. And the outermost layer down there is data sources, which is definition of and the concrete implementation of how many of the different data sources that we can have in our project. In our case, it can be a database, it can be a network interactor, so some component that goes out to the network and retrieves data. One thing that to note, generally speaking, about clean architecture is that the fact, as I mentioned earlier, about the concentric and the immutability of layers. What we can affirm if we follow clean architecture is that we have use cases and entities being the most centric part of the app are the ones that are least likely to change throughout the lifetime of our product. So if you think about that, about unused reading app, when is it ever going to change the fact that we're going to retrieve our news sources, like generally speaking? Never, because if we have this kind of project, we're never going to change it. If you move towards the outside, if you think about presenters and activities and fragments and model view model, or all that kind of logic, it's all technology that evolves through time. And clean architecture is especially built to facilitate our ability to change these kind of technologies without touching any other part of the app. And then we're going to see it later. And especially also talking about data sources, which is the concrete implementation of data sources and data layers. If you think about Room or SQLite in Android, Room was just a later addition, or all the kind of networking libraries that we have. They are due to change throughout the lifetime of our product if it's long enough. So clean architecture facilitates our ability to interchange these kind of components, while the inner components are least likely to change. So more generally speaking about clean architecture, we can define 5 layers in this case. The domain layer, which is the most important layer, and it sits at the center with the presentation and the app layer and the data and data sources layer. Another principle of clean architecture is probably the most important one is the dependency inversion rule, which states that all these layers, as I represented them here now, which are only 3, but we can compress some of them. So, yeah, for instance, in this case, it could be sorry, these are 5, but we can think about 3 as app and presentation together and data sources together, but still keeping the domain separate from the other. Again, the dependency injection rule states that the interactions between these layers, so the boundaries represented by these circles, are to be interfaces, are to be not concrete parts of the software that we can use to make the layers communicate between each other. And the arrows that you see pointing inwards is just that the dependency inversion rule, which is, by the way, one of those concepts defining solid, as you probably heard about that, means that in this case, for instance, the dependencies must point inwards. So the domain layer that we see here has no dependency over anything inside our project, whereas all the other layers that we have inside here have a dependency on looking inwards. So we're going to have at some point a data layer which is going to depend on the domain layer and is going to offer a way to have a dependency fulfilled by data sources. So there's a data sources that depends on data, and data depends on domain, and the same from the upper level. So to quickly recap it, having this kind of architecture inside clean architecture allows us to separate the concerns between the components in our app, and the powerful concepts behind the power of this approach is that we can have layers which are completely separated from all the Android framework, which is quite powerful if you think to build a project which is going to be run in several different platforms. I want to mention just Kotlin multi-platform, or also you can build a backend or a front-end application on web using Kotlin as well. You can just literally copy and paste these 2 models, which are domain and data, which are pure Kotlin at this point, and they are going to work out of the box. All the other layers that you see, app and presentation layers, of course, have to include a dependency on the Android framework in this specific case, because of course we have to make use of the Android framework stuff. And data sources, there's a plus between those 2, because if for instance we are using just a network library, which is Java or Kotlin, we cannot make use of any of Android dependencies on the framework. And if we use Room, for instance, which is very tied to Android, we have to include the dependency on Android framework. So there are some good things about this, which I stated here. So the clean architecture allows us to have a loosely coupled layering in our software, which means that having abstractions between layers, we can interchange the concrete implementation in each layer, as long as we rely on the fact that we have interfaces between the components the components are really not aware about each other unless you change the interface. So say that tomorrow I want to change completely the implementation of the networking library or the network, how my network interactor works. I can do that without the other part of the app being aware of this, which is very powerful if you think about that. And it's got many more advantages that we're going to see later. It's framework independent, again, as you can change technology easily. It's readable if you keep being strict about having a nice architecture and clean it properly. It's going to be very easy to read. It promotes testability because if you introduce many interfaces on your components, you're going to be able to use unit testing very easy, very out of the box. So you can test an interface with of course a concrete implementation underneath, and just keep on iterating on that. So you have a nice way of repeating the task. Reduces costs because it makes it much more difficult to introduce bugs, makes it more easy to spot bugs, and also it reduces devs burnout and your happiness. And it can be scaling relatively well with respect to other unarchitectured components because I mean it's separated enough that you can make it spawn much larger. One other topic about this talk is the modularization. We're going to try to see if we can make it work together, as you see here as well in this slide. There are of course many approaches you can take when modularizing a monolithic app, which is a unique module. As an Android app, you can separate it by feature. As you know, you can have a vertical slicing of your product where you have a module which is devoted to just cover a single function. Then you can compose any other app using a selection of these modules, and also introduce dynamic delivery, so some modules can be optional as well. And you can have the separation by layer instead, which is something that mimics the stuff that we just saw about clean architecture. So you could still have a project which is layered by app presentation, domain, data sources, and data layers. But this has got clear disadvantages when working on a feature. You're touching a vertical slice of this horizontally divided product. So you're going to touch each and every layer. If for instance, you're adding a new screen that is going to go to the network, you have to go down all the layers. And this is one of the drawbacks against these kind of things, because it can scale up to be a very big change and not a very good way to collaborate with other people because mainly conflicts or any other stuff that you can think of. So why not thinking about an hybrid approach that we can have in this case? Why don't we try to have a vertical slicing, which is keeping the advantages of having features, so having all the advantages of having separated features, but also introducing a nice architecture inside each layer. It's going to be a little more difficult to keep it clean as much as we would have via layering, because we don't have a separation between the layers. So this approach is the one that we're going to see now, and we have as long as our product is going to grow, we have to be very strict about ourselves and about our standards of coding. But if you can do that, I can assure you that the end product is very nice. One drawback about this approach as well that we lose with respect to the others is that we lose the ability of having pure Kotlin modules in this case. So each feature module that we're going to have is going to include the Android framework dependency if it's an Android screen, which is most likely going to be. So we're going to have each module, as you saw earlier, is going to be composed by dependencies on Kotlin in this case and Android. So once more, why do we want to modularize, generally speaking, an Android app, an Android project in this case? Because it allows us to have faster builds, especially for incremental builds. As Gradle is very sophisticated, it can do some magic, some parallel computation, some selective compilation about modules that you modify. It simplifies development because it breaks down the code in much more streamlined way, so we have to make much more good thought choices. It allows us to have reusable modules in a way. If you want to if you want to build another product which has got, again, a selection of features. It splits responsibilities, so it's very nice to be introduced into a team, because whenever a team is working together, you can have a team that is working on feature A, a team is working on feature B, and have a nice interoperability around this. It simplifies test automation, because you can, as we're gonna see later, there's some tips that you can have to make the UI tests run much faster and be a little more reliable. As for my experience, UI tests are quite a pain. They take a lot of time. They take a lot of expertise to be set up, and it's very difficult to do it on a large scale. And also, again, it allows us to make use of dynamic delivery and dynamic feature modules if we want to have an app which is only 3 core modules, and then the user is going to go ahead. If he wants to use like a card scanner feature, as we did in my previous company, it has to go to the network and download like a 20 mega library that you're going to use once in your lifetime as a user, or something like that, which can be a pretty big advantage if you think about the average size of Android apps. So, which is our sample? Let's go to our sample. This is just a very simple app. This is an app that, as I told you already, it goes to an endpoint, retrieves a list of news articles, lists them in a list. And just for the sake of simplicity, whenever you click on one of those articles, you're going to see a list of sources, which for the sake of this example, is just doing the same thing, but it's just adding some more complexity that we're going to see later. So where do we come from, and where do we going to go? We're coming from a monolithic piece of software, a monolithic Android project, which means having just a simple app module, which is going to have all the dependencies, the Gradle dependencies, and everything inside, to a modularized app with a clean architecture inside, which have a series of modules which has got a nice separation and a meaningful dependencies between them. So there's a nice tool which is called Project Dependency Graph by Jake Wharton. You can run it via Gradle. It works out of the box and gives you a representation of how your project is laid out dependency-wise. This is not actually for the monolithic app, which means having, again, just a simple app module. This is not the real output. I had to build it up because the real output of the script is just a blank thing. It doesn't tell you anything. So I just for the sake of representation, we're going to have just an app module for the monolithic app. And I'm going to show it to you now just quickly, so you can have an idea about how it's done. I hope that you can read good enough. So we're going to have just this app module. So this is going to be structured like this. As you can think of just a basic project like this, it's got some very bad things inside. Generally speaking, we're going to have a main activity which is going to, come on. Why? Sorry about that, guys. Apologies. Let's see if we can go ahead. Yeah, so we're going to have just a simple activity in this case, which has got a fragment with a view model, which is going to make use of data source to retrieve data, and just to make sure that we have the data returned in this case. The data source is built like in a very bad way. It's just a concrete implementation with a couple of feed services using retrofit. These two interfaces, such as this one, for instance, is GetFeed or GetSources. It depends which one we want. And yeah, it's basically it. So it looks like this, just a concrete implementation, just a concrete implementations and just a simple module. Our objective is to go from this one to this one, which is the one that I built out of. I did it the other way around, but yeah, you can achieve this kind of objective in the lifetime of your project. So which means if you factor out the image loading, module, you can think of having the app module, 3 feature modules, which is give me the sources, give me the feed, or give me the detail of one of the news that I saw in the feed. And you have some basic modules that we can reuse throughout the features that we have in the middle row. And which are selectively, can be used selectively. If you think about detail, which in our case doesn't use network at all, doesn't need to do a network resource, network calls, it's not going to use it, and it's going to be much easier to, it's going to be much faster to build as well because it's got less dependencies. One cool thing about this thing that I wanted to tell you is just Gradle, going back to Gradle and its complexity and how smart it is. If you modify anything inside the network module, for instance, it's going to provoke just the rebuilding of the sources and feed module and the app module. So you can be sure that the incremental build times are much less than the single module project because we're going to exclude image loading, core utils, style and detail modules from being compiled, so it's going to be much faster just by a thought of logic. So our final result would be we would point to go to something like this. So having an app module, a feed module, a sources module, which by the way are going to do pretty much the same thing, are going to be an activity with a fragment and a data and a model view model. And another detail module, for instance, is a feature module. And we can build an app selecting any of these like 3 features, detail, feed, or sources. We can just do an app with feed and nobody else is going to complain. So let's dive into a little of the logic that we have in here. So if you go ahead, let's start discussing about layers, and also let's start having a little discussion about how clean architecture unleashes this power via introducing some principles that we have to follow. Let's look at entities. This is a D represents a data class or an immutable object that we have inside our layers, and clean architecture as a general approach tells us that we have to have a concrete model of our data inside of each layer. And we are going to make use of mappers to translate between data objects within one layer and the other. And this is going to be true for almost all the layers, and you're going to see it later. So in this particular layer, which is the most important, again, the domain layer defines entities, also known as business objects, which are data objects which contain logic and rules that are needed to carry out the business logic about the app or the project that we're going to develop. In this case, it's very simple. It's going to be just an article, and it's going to be true also for other layers. We're going to see it soon. And it defines an interface for repositories. So as you remember, the domain layer, the data layer has got a dependency towards domain layer. So the domain layer is going to define a repository interface through which the domain layer is going to fulfill its purpose. So I want to retrieve the news, so I'm going to have an interface which is going to be fulfilled as a repository, and which is going to give me the list of articles. And then we have use cases. Use cases are the verbal, let's say, phrasal representation of what we can do in our app and what we want to do. And use cases are going to be used later by the view model when it is carrying out its duty. So if we go to our example, I open up GetFeed. We're going to see GetFeed in this case because otherwise it would become too long. But if you look at the packaging of this one, you can already see that I decided to separate between data domain, presentation, UI layers. And then we have 2 different data sources, which is remote and local. In this case, I'm using Room and Retrofit to do network requests. Going back to our topic, in this case, is domain. So we can take a look at GetFeed use case, which has got is an extension of a base class, which is called observable use cases. It's got dependencies, just 2, a background scheduler and a foreground scheduler. This could easily be in another base module inside this project, because we can reuse this one, which is very generic. Let's go to the concrete implementation of this guy. It's just going to use, as I told you, a feed repository interface representation that we're going to see soon. and these dependencies that we're gonna give and is gonna fulfill to his parent. And the only thing that is actually gonna do is using the repository to do the GetFeed. So we're gonna generate this observable and just use it later. What is this observable going to return? This observable is going to return a list of feed article domain entity, which is the data object that I told you it's inside entities, and it's got a representation of an article, an ID, or anything else. The repository, let's go quickly to the repository. As I told you, it can do a number of things. In this case, we're just going to use the GetFeed ability. So it's going to, again, return, this is just the interface definition that we have in the domain layer that we're going to fulfill in the other layer. So, and this is just going to return a list of feed domain article entity, which again is the business object of this project. So let's move down and go to see our data layer. Let's start from the right again. We have data models. Data models are pretty same representation of the stuff that we have in the business object, in the business objects. This is just a matter of chance. They could be completely different. And it's just a representation of data that we are going to handle inside this layer. We have the repositories concrete implementation, which is, again, we define the repositories up here, and we're going to implement them down here. The repositories concrete implementation is a repository pattern. It's a component which is going to have a number of data sources, 10, 100, 1, and it is going to orchestrate the retrieval of data throughout these data sources. And we have the data sources interfaces definition on the left, which are going to be fulfilled by the data sources layer that we're going to see later. So if we open up who is implementing this feed repository interface, we're going to be brought to the data layer. And we see that this feed repository, as I already told you, has got some dependencies on a couple of data sources. We could have a number or just one. And this is just the concrete implementation, which is, by the way, for the sake of this talk, this is just an implementation detail that you can do 100 different times, on your own. This repository has got the 3 dependency, really, because one dependency is about mappers. Mappers, in this case, are necessary because they are the translators between the data between layers. So, as our repository is asking to get domain entities back, when we do a concrete implementation of the repository, we're going to have a different object back, which is going to be the ones that we get back from the feed local data sources and feed remote data sources, in this case, which is feed article data. And this is the data class pertaining to this layer, which is very similar to the other one. It could have a subset of info, or maybe possibly more, because it's more towards the real data that we're having. So what do we do? When we retrieve the data from these 2 data sources, we have to translate it between being a feed article data and a feed article domain entity. So we're going to have just a mapper that translates between one object and the other. This mapper, in this case, we have the ability of knowing what we are depending on. So we know that feed article domain entity exists and belongs to the domain layer. And we are translating between, again, that layer and our layer. And then we're going to see which is as I told you, it's the power of clean architecture. Is one of the powers of the clean architectures is enabled by this. Again, let's go back to our feed remote data source implementation. In this case, it's much simpler. The local data source, it looks like this. It does something else, such as saving and removing stuff from our local database. But we're going to see this one in this case. It's again a GetFeed, a simple observable, which returns a list of feed article data, which, by the way, again, is the data model that we defined here. Which brings me to discuss about the next layer. So we are going downwards, and we are in the outer layer, and which concerns data sources. Data sources, again, we have data sources models on the right, and this is, in this case, these are the representation of the concrete data that we get back from the network. This is an API model. This is stuff that comes out from the network that we use to do our business. And then we have the data source concrete implementation, which are the concrete implementation of the interfaces that we defined here. So we are constantly moving towards the external layers. And so we see who's implementing this one. And we end up being in the remote layer, in this case, which is, by the way, built like this. It's got a field service, which is very similar to the other one where we saw, which we saw in the single module project. Again, a data network mapper, which is going to translate between the API model and our local model, which looks like this. Again, it's which looks like this. Sorry, which is the data layer. And our local model, again, sorry about that, is the API model representation. So the data source implementation implements this data source. It's got the dependency on the feed service interface, which is a retrofit interface, the one that we usually see, and makes use of the feed article mapper to map between API models and data models, which are going to be in turn translated into entity models. So the data flow comes from down and gets translated each and every layer up until where we need it. So now we just got to the bottom. We were in the data sources. So now we're going to see how our presentation layer is done and how it's going to make use of the layers that is underneath it, which is the domain layer. The domain layer, again, is the central part of the app and defines the business rules and the use cases that we're going to use in our view model in this case. We have UI models, which are the presentation of data ready to be shown to the user. Again, this is a data class, a Kotlin data class, which contains data that is ready to be shown to the user, such as formatted dates or anything like that. I don't do any of this in this particular example, but you can think of like a formatted data or some kind of text, formatted text that comes from the object that we have underneath us. And this got the view model, of course, as a concrete implementation. So the presentation layer looks like this. It's got view models, which is the definition of the core of this view model. So it's just a typical Android view model. And it's got two dependencies. One is about the mapper, which maps between the domain entity and our UI model, which is, in this case, feed article. Again, it's just like a series of stuff that we can show to the user. And we have a dependency on the GetFeed use case, which is what is this view model going to do? It can do a series of things. It can have a number of use cases. So if this view model also makes a Twitter call to some endpoint or something like that, it can have a post to Twitter use case or something like that. So we can make use of a number of use cases. In this case, we have just a simple one. And again, when we generate this use case, this parameter is just a parameter that we can give to the use case to build any of these requests or anything like that. And it's going to return, the chain of calls is built such as whenever we call on this use cases, get me the feed, is going to call the chain of repository that I just shown you, and is going to make the data flow back via the mappers. And again, it's going to make the data flow up with yet another mapper, which is going to translate between the domain data object and the UI object. One cool thing about this is that, and now one cool thing about this architecture as a whole is having RxJava at its foundations. So as long as we have an RxJava chain sitting underneath ourselves, we can transform an observable into a live data. And this is going to be particularly cool when we are observing this live data, this view model. Sorry, we're going to generate a live data out of an observable. In this case, the data flow is going to be again coming from the data sources up whenever we subscribe to the data source to the view model. So whenever we're going to start observing the view model, we're going to trigger the chain of calls, and we're going to have back a live data with a resource of list of feed articles. Resource, by the way, is just a class that is a wrapper between successes, loading, and errors that you see here. It's just a common pattern that we have in our fragments. If we go back quickly to our presentation, Sorry about the words. So we are going up and seeing our UI layer. Our UI layer is very thin in this case. We just have an activity which is hosting this fragment inside itself, but it can be a little more complex if we have several fragments that do several things inside this feature about reading the feed. And it depends on the presentation layer, of course. So we can make use of the view model that we just defined into our fragment and just show the data to the user. One thing that you can see here again is another outermost layer which is likely to change throughout the lifetime of this product. Say that tomorrow we have a completely different, super cool way of presenting stuff, or we have another fragment to whoever is going to introduce it. We can quickly change it and just making use of the use cases that we have already, and the data flow is going to be the same as before because we're not touching anything else. Quick, big word about navigation. How do we translate the concept of having a single module app and going from a part that is always known to us? Because if we have a single module app, we always can navigate from one point to any other point inside our project because everyone knows about each other. Now we are separating between features, yeah? So how can I navigate between one article in the list of feed or in the list to the detail feature? How can we do that? And how do we do the internal module navigation? The internal module navigation stays the same. We can use the explicit intent, call another activity, or even better, we can make use of the navigation API from Android, which is much easier. We have a single point of access into this feature, which is going to be feed activity, which is going to have a feed fragment and a series of fragments inside itself, and then you can navigate throughout each other in a very streamlined way. You can keep doing all your usual business if you want. Cross-feature navigation instead is an interface in this case. If you look at that, and the cross-feature navigation is defined like this. There's many other ways you can do that. It's one of those pitfalls of these approaches because you could run into problems when trying to figure out how to do that. Some people just use deep links inside the components of the app, so you don't necessarily need to know about anyone else. Some other people just use implicit intents, which I don't really like, just on a personal perspective. And another very simple approach we can have in this case is just have a navigation interface inside our feature module. So we're looking at the interface feed navigation. So we're coming to a feed article that is inside. This is the UI model that I showed you earlier. So we're navigating from this one to a detail of this news. But the detail is in another place. It's in another feature module, which is this one. It's just a simple MVP in this case. So you can see also how easy it is to use different architectures between the same project. So I am MVVM for the feed, MVP for detail. Who's gonna fulfill this interface? How can I do that? If you think about the scheme that I showed you earlier, there's only one module inside this project that knows about everyone else, which is the app module, the topmost module. So one of the roles of the app module in this case is to be implementing these interfaces and offering us a way to go from A to B inside our same project. So we go back to the father and then look for another children to fulfill this navigation need. So if you look at the navigate to the detail, for instance, we see that we have an explicit intent to the detail activity because we know about it. We are in the topmost layer, which has got dependency over everything else. We define this as an explicit intent, and the bundle, the stuff that we bundle inside, in this case, can't be a feed article because feed article belongs to the feed feature. So we're gonna translate it into a UI ready thing to be used into the detail layer, which is called article detail in this case. As you see, it's got a subset of stuff because through the detail of this article, I don't need everything, which is again defined as a model inside the detail module. So we are fulfilling the navigation by translating again, having a mapper, which we could introduce in this navigator. I didn't do that, but you can easily do that. A mapper between one UI model and the other UI model that belongs to the correct destination. Yeah, and that's pretty much it. There's plenty of different solutions to this, as I already mentioned. Talking about, again, iterating on the app level thing. We have a main activity as a launcher activity, which is going to launch, is going to be very shallow and launch one of those single point of entries that we have inside our features. In this case, when we launch the app, we're going to launch the feed activity, which in turn is going to have a feed fragment, which is going to subscribe to the use case, which is going to trigger everything. And we have a navigation concrete implementation, as I just shown you. One big thing, the one that I didn't want to talk too much about inside this in this talk, is dependency injection. If you remember all the concrete implementations that you saw here, for instance, about this remote data source, we have dependencies. Who are going to fulfill these dependencies? Who's going to give me this dude with all the correct stuff that I want inside? We have to have the dependency injection. We have to have Dagger. Or in this case, for this example, since it's very simple, and I really suggest you to take a look at, since it's a very nice example of dependency injection. It's Coin, which is a very lightweight library, but it does dependency injection on a runtime fashion, so it's less performant than Dagger, which stays the same and stays the standard as for now about dependency injection, and just gives me a series of directives that I have to fulfill if I wanna have a feed service. I define that as a singleton, for instance, in this case, and I just call my retrofit, which is defined somewhere else in my tree, which is going to give me a concrete implementation of retrofit, which in this case is inside the network layer, which is completely separate from anything else. And so each module inside this DI package, I put stuff for each module. And so each module is going to be offering the dependency graph a way to get a concrete implementation. If you think about, whenever I'm going to ask the system to give me, hey, I want to feed local data source, the system is going to be able to do that, and it's going to be giving back a concrete implementation, as you saw, I showed you earlier, with the correct dependencies, which you can get them by name or just by type, by interface that you define in here. One other nice tip about this, to help you keep it clean, the concrete implementation always are behind an internal qualifier, so that makes it only usable within our package. So we're not gonna be using it outside for any other reason. We're not gonna see it at all. So the only thing that we are gonna see is the repositories, which is actually the principles behind all of this. So only the repositories must be visible outside from this module, and the concrete implementation is just a concrete detail that it could change any time. So as long as you have a stable interface, everyone is going to use that interface, and you're going to keep on doing an iterating on this fashion. Another quick big word about testing. As I already told you, the instrumentation testing, which is, by the way, also known as UI testing and all the likes, it's facilitated by the fact that we have a single point of entry for each feature, because whenever we want to access one of those features, we're going to access it via just one way of getting into that scenario. So we can test it in isolation. So I can have a UI test inside my feed feature, which is going to say, hey, launch me the feed, but I want this with this stuff that I got who knows where from outside. If I have some initial data to launch it, I can test it in isolation. I can launch this screen in isolation. This is very good for performance-wise. UI tests can take hours. In my previous company, they were taking like 3 or 4 hours to run. It was like 2 or 3K tests. So in this case, you are saving much more time, because to build a UI test, it's an actual, you have to have an emulator with an actual app that is running and that it does stuff inside that app. If I'm going to the launch of app to the detail screen, I have to go necessarily through the feed feature. This is going to take a lot of time, because I'm going to mock the feed feature. I'm going to mock the click on the first one. I'm going to see that I write to the right point and stuff like that. If I have an entry point to the detail feature, I can just launch an intent to the detail with the given data that I want, and I can test that screen. Unit testing, Yeah, I can show you a quick example about unit testing. If we are thinking about this repository pattern, having these interfaces simplifies a lot the introducing testing. Makes us life much easier when we are going to build a test for it. All tests run via JUnit, so very quick. We're talking about like milliseconds per each test, or tens of milliseconds. So we define an object as being an under test, so we are testing this component in this test, which is a feed repository, which is an interface, please note. And we actually initialize it with a concrete implementation, of course. And we are using a concrete implementation of the domain data mapper, which we don't really care, and we are mocking the interfaces that we want to act on. So in this case, I have a test about getting feed, remote call succeed, change local call and saves local data. So we are mocking the remote data sources to be a success, to give me a feed article data, which we have built out of purpose in our test data object. And then we can mock each and every call and every result. I can test the GetFeed remote calls and local call fails. What is going to happen? We're going to have a success on the first, but we're going to have an error, a throwable at some point. So I'm going to have just one value getting back just one value, and I can test all the other things. Inside this project, I already added several tests. I think there are 15. So I'm testing everything that I built, every single concrete implementation about this, including the GetFeed use case. The use case is very simple. Succeed fails. Make sure that I get the error thrown back up the chain until I see it in the UI. So that's a lot to discuss about testing and how useful it can be for you. It can be just a lifesaver whenever you're changing anything inside your app. You are sure that as long as the unit test is correctly written, you're going to be reasonably sure that it's going to be a good change and not break anything. So basically, a 5x5. What did we achieve in here? We have most likely reduced our build time, especially for incremental builds. For clean builds, it can be or not be the case because of parallel execution or anything like that. We have increased the test coverage, or at least the testability of our pieces of code. And we are not putting all of our buy-in into our specific implementation or library or anything. So think about developing a complete application, just making use of MVRX or MVI core, which are libraries very nice, super powerful, but they are from private companies which don't have any other obligation towards you to keep on developing on that. So there are some companies that currently have a fully functional product which is making revenue for them, but they are so tied to a definite libraries from other private companies that they are really struggling to make sure to have that revenue and be iterating on that, and the initial company has abandoned development. So you're basically buying all of your revenue inside this company. So we're actually not doing that. We are just using standard stuff and reactive on top as a foundation of our code, which makes it much more cool. You can even go even further and use coroutines in this case. And we are making use of Android architecture components, which you know very well that is a pretty cool thing. So tips to actually start to think about that and to actually implement this in your company or your project. So have everyone on board is important, because having all these kind of translations of data, data classes which are static throughout lifetimes of each layer can be a pain. They can explode in numbers, but as long as you stick to it, you're still gonna make use of the power of clean architecture. So you have to agree with your team that everyone is cool with that. Everyone is gonna keep on repeating on this. So you have to consider increasing the test coverage before you do stuff, or you can do it on the go, and also Kotlinized files. Why not? Start using Kotlin 100%. So you have to come up with a plan and commit to it. So you're going to be comfortable. You have to be comfortable with the fact that your project, if it's very big, is going to be for a possible long time half cleaned and half very dirty and shitty. So you have to commit to it. So you have to make sure that 3 hours per week, 4 hours per week, you can work on this and start improving on that. And on this, I have to suggest you to encourage pair programming and duck rubber duck programming, which makes the discussion between developers makes your life much easier because you make much more informed choices, and maybe not everyone is on the same page. So as long as you discuss about it and you keep discussing about it, makes it much more easier and much more difficult to make mistakes. And so if you start from small, conceptually separated parts and then iterate, which is of course, as you think about it, a wise choice to do. If you think about having an analytics concrete implementation that you can put behind an interface and maybe stick out to a separate module, you're not going to be compiling it every time that you run again the code. And if you think about that, it can be quite powerful. If you have an SDK or anything like that, you can put it outside and put everything behind an interface, just a general suggestion. Or even you can go even further and try to start do cleaning code to do the clean architecture. So yeah, there's no silver bullet. There's no like perfect recipe for everyone. The investment in time is gonna possibly be very big, but this probably is gonna make you much happier and much more able to just grow and scale and have your product work very nicely and not make you work like 10 hours a day, all days, which is quite a good thing. And so is it really worth to invest time to do this? Probably yes, probably no. Probably it's worth to investigate on this and try to make your life easier somehow. And also the users are not gonna see anything about this. So it's pure like about your own happiness and inner peace. So which is the optimal trade-off between having a perfect architectured app and a nice app as well, or an app that just works. So yeah, all stuff that you have to think about while you think about doing something else, something like that, or something else to your current approach. So you find some useful resources in here. There are plenty more. It's just I think these are the best ones that I found while developing. And yeah, that's pretty much it. Thank you. Questions? You can catch me later if you want. Or, yeah.
What if my company has, for example, 500 different projects?
Yeah.
Can I use this kind of architecture? Each model should be increased. I mean, can I use this model for each project?
Of course you can. I mean, if you have a...
Because they different projects have different requests.
Yeah.
So it's good to have all this model going for different projects?
Well, it really depends. Probably you can build out a library of your core components or of your core things, and then if you are constantly customizing on anything or on anything inside your project, probably you have to really step back and start to thinking about how the grand scheme of things is done, in my opinion. I never had this kind of experience, but I just can tell you out of principles about this. Probably you have to think about a more streamlined way to just iterate on customizing these kind of things and just build an internal SDK, for instance. For your company, you're going to put an interface, yeah? So if we're talking about interfaces in a concrete implementation about stuff, the interfaces are quite powerful if you think about that. I have to, I don't know, do this code because I always do that to my backend. It's going to be an interface which you're going to always call against that interface, have a concrete implementation which can change throughout the lifetime of your company. And whenever it changes to the last specification that you have. But if the interface stays the same, all of your product, you can take the concrete implementation, copy paste to the new project, and nothing is going to change. Of course, I mean, I'm making it much more, simple, but I know that the complexity about working together with other people has to be addressed, as I told you already. So it has to be a really, you have to be to really be into it and invest into it. But if you get the right spark, the right, inspiration about changing stuff, maybe you can iterate on that. Maybe extract, as I told you, a small component and try to see if you can make a more composed things, or composed project, with things. Yeah, let's say that you have. Yeah, definitely. So say that you take out the network module if you do API, So I mean, this is you put it in your GitHub, and whenever you add anything else, you pull from that module and you include it in your new flavor or whatever that is on a new product. And then you can start iterating on that. Once you define the core foundation of this, you already done a nice job, because you're factoring out stuff that is going to stay the same for a potentially long period of time. Say, I mean, API keys, headers, about networks. You don't need to care about this anymore in your next iteration. Of course, yeah, you have to think about nice approach to do that. And then I iterate on that. I have this feature that is showing me a list of transactions that is going to my backend and just give me the transactions from the client A. And it's going to be possibly a module with a view model, which is going to use that network model, that network interface, to just do its stuff. So you extracted the list of transaction feature module, and then you put it on the GitHub and you start pulling it. And whenever you're going to change it, you're going to change the one that you have in the centralized repository, of course. And whenever you do an update and an upgrade, you're going to have just the latest concrete implementation. As long as you keep sticking to the interfaces, in my opinion, which are hopefully, if you engineer it good enough, they're going to stay the same throughout the lifetime of your project. You're going to change the concrete implementation, which is one of the powers of the clean architecture. Yeah.
Can we download the example code?
Yeah, I think I have to work on it. I have to exclude some stuff, but I can make it. Yeah, definitely. I don't have it public now, but I have to work on it. Cool. Good. Thanks, guys. See you later.